Why has Earth kept spinning for billions of years? Beneath our feet is a massive sphere weighing roughly 6 sextillion tons, yet it has continued rotating steadily for about 4-6 billion years. A simple spinning top falls over after only a few minutes, but this enormous world has kept turning with astonishing persistence. Does that mean Earth is a perpetual motion machine? No, physics leaves no room for perpetual motion machines. The idea violates the law of conservation of energy and has long been rejected by science. Earth is no exception. The reason it has kept spinning for so long is much simpler. When it formed, it inherited an enormous amount of angular momentum, and over billions of years, almost nothing in space has been able to take that momentum away. To understand why Earth rotates, we have to go back 4-6 billion years before either the Sun or Earth even existed. At that time, there was only a vast, chaotic interstellar cloud known as the solar nebula, made mostly of hydrogen, helium, and debris left behind by ancient supernova explosions. Under the pull of gravity, that nebula began to collapse inward. Because the collapse was uneven, the cloud started to spin, and as it shrank, its rotation sped up. This is the principle of conservation of angular momentum. If a rotating object is not acted on by an external force, it keeps rotating, and if it becomes smaller, it spins faster. It is the same effect you see when a figure skater pulls in their arms and begins turning more rapidly. Eventually, the dense center of that nebula became the Sun, containing 86% of the mass of the entire solar system. The remaining material, less than 14%, formed a giant rotating disk around it. From this disk, through countless collisions and mergers, Earth gradually grew like a snowball, rolling larger and larger. Earth's spin was not random. It was inherited from the angular momentum of that original nebula. When Earth first formed, its rotational axis was probably more upright, but then a Mars-sized object, which scientists call Theia, slammed into the young Earth with tremendous force. That impact tilted Earth's axis by about 23.4 degrees relative to the plane of its orbit. It was one of the most violent events in the history of the solar system, taking place around 4.5 billion years ago when the planets were still forming. The collision not only made Earth larger, but also blasted huge amounts of debris into space. Over time, that debris gathered together under gravity and formed the Moon, our planet's only natural satellite. That tilt is also why Earth has distinct seasons. Other planets do not experience them the same way. Mercury, for example, has almost no axial tilt, so it does not have seasonal variation like Earth does. Earth's tilt allows sunlight to shift across the globe throughout the year, producing spring, summer, fall, and winter. The giant impact may also have helped shape Earth's internal structure, including its large metallic core. The movement of molten iron deep inside the planet acts like a vast generator, producing Earth's magnetic field. That invisible shield protects the surface from solar wind and harmful cosmic radiation. Without it, life as we know it would have had a much harder time developing and surviving. So why does Earth not stop spinning like a toy top on the ground? A spinning top slows down because it faces two major forces: friction against the surface beneath it and air resistance above it. Those forces steadily drain its energy and turn it into heat, but space is a near-perfect vacuum. There is no air to slow Earth down and no surface rubbing against it. So once Earth began spinning, Newton's first law tells us it would keep spinning unless a significant external force acted on it. Earth's enormous mass also matters. With a mass of about 6 sextillion tons, it has tremendous rotational inertia. In general, the more massive an object is, the harder it is to stop. To bring Earth's rotation to a halt, something on a planetary scale would have to apply force to it continuously for a very long time. In the present solar system, that is essentially unimaginable. Things like interstellar dust, solar wind, and even meteor impacts are far too small to matter much. Still, Earth's rotation is not truly eternal. It is changing very slowly all the time. The main reason is the Moon. The Moon's gravity creates tides on Earth, and those tides act like a subtle brake on the planet's rotation. Scientists estimate that over time, this tidal braking lengthens the day by a tiny amount. Hundreds of millions of years ago, during the age of the dinosaurs, a day on Earth lasted only about 21 to 23 hours. If you could travel back then, you would find the planet spinning noticeably faster than it does today. The Moon is not staying in the same place either. It is gradually moving away from Earth at a rate of about 3.8 centimeters per year. This is a direct result of tidal interactions. As Earth loses some of its rotational energy through tides, that energy is transferred to the Moon as orbital energy, pushing it farther away. As the Moon recedes, its gravitational influence on Earth changes, which in turn affects Earth's rotation and tidal cycles. The sun is another factor. Through nuclear fusion, it converts about 4 million tons of matter into energy every second. As the sun slowly loses mass, its gravitational pull weakens slightly. As a result, Earth gradually drifts outward at an estimated rate of around 1.5 centimeters per year. That means Earth's orbit slowly expands, and the length of the year increases very slightly over geological timescales, though the change is far too small for any human lifetime to notice. Yet even amid this long-term slowing, scientists have observed unusual short-term changes. On June 29, 2022, atomic timekeeping stations around the world recorded Earth completing a full rotation about 1.59 milliseconds faster than the standard 24-hour day. That set a record for the shortest day measured since modern records began in 1969. Scientists still do not fully agree on the cause. Some think it may be related to motion in Earth's core. Others suggest melting polar ice, shifting water masses, or changes in the crust may be altering how Earth's mass is distributed, which can slightly affect how fast it spins. In other words, even climate-related changes may be subtly influencing Earth's rotation. In the end, Earth has kept spinning for billions of years for three main reasons. First, it was born from a rotating nebula and inherited that original angular momentum. Second, space is almost empty, so there is essentially no friction or drag to slow it down. Third, Earth's enormous mass gives it tremendous inertia, which makes its motion very difficult to change. At its core, Earth's rotation is really a story about the transfer and preservation of motion. From a chaotic cloud of gas and dust billions of years ago, through collapse, compression, collision, and formation, that original motion was passed along and preserved. The Earth spinning beneath our feet today is the latest heir to that ancient momentum. Every 24-hour rotation is not just a cycle of day and night. It is an echo of the early solar system, still carrying the motion of its birth into the present. And although the moon is slowly reducing Earth's spin, the planet is unlikely to ever truly stop rotating before the sun enters its red giant phase in the distant future. So yes, you can rest easy. When you wake up tomorrow morning, Earth will still be turning just as usual.